Alright, here's our 1.5 homework video. We'll get started right away with number 3. It's asking us to find the difference. Okay, in this situation, I'm going to leave my first number alone, and I've got minus 7, so this is going to result in a chop slash. Okay, make the 7 negative. Now what I have is I have 12 negatives and 7 negatives being added together. Right, same signs mean we add, which would be 19, and take this similar sign, which is negative. For number 7 and 8, we're going to order the values from least to greatest. One thing I like to do is I like to re-rate each of these after I've taken either the value or I've looked at them to make sure they're in their correct form. Okay, when I do that, I'm going to change the absolute value of 3 just to 3, and the absolute value of negative 4 is 4, so I'm going to do that. My correct order then would look something like this. My negative number comes first, then negative 2. Then from there, it's just ordering positive numbers. Okay, 1, 3, 4, and 6. Okay, the official list will look something like this, right? We go back and we say, what did they start out as originally, right? And there we go. So this would be my list right there. For number 8, I'm going to do the same thing. 4.5, negative 3.62. This is going to change to positive 1.8, and this is 1.2. All right, let's start doing this again. Negative 3.6 comes first because it is the only negative I see. Then from there, 1.2 is next. 1.2 is smaller than 1.8, so 1.8 will come next. I'm going to write it in its original form. Then we have 2, and then the absolute value of 4.5. All right, the next 5 I'll deal with today's lesson, which is subtracting rational numbers. So again, our 2 forms that we should look for is karate math only works with subtraction, and when we have it, if I see one negative sign, I'm going to chop slash, okay, which the chop makes the minus sign turn into a plus sign, and the slash turns the second number negative. Okay, if I have a double negative situation, so a minus a negative number, this is when we chop chop, which again turns my minus into plus, and then turns the second number positive. Okay, so number 11. Again, I like to draw this little line here that says don't touch the first number. That one stays. After that line, I see there's 1 and 2 minus signs, so I know this is a chop-chop situation. 5/8 is going to turn into plus positive 7/8. Okay, I have common denominators. I'm good to go. I get 12 over 8, which could simplify down to 3 over 2. Okay, 3 over 2 works, or we can say 1 and 1/2. There we go. Number 16, again, draw your line. This is the reason I draw that line, because we always are looking after the first number. Sometimes we get the negative attached to the first number included in there. Nope. Okay, there's only one minus sign after it, so this is a chop slash situation. Minus 5, chop slash plus negative 5/3. Okay. If we change this, I can write negative 5 over 1. And then I can see to go from 1 to 3, I need to multiply by 3 on the top and bottom. So when I do that, I'm going to get negative 15 over 3 plus negative 5 over 3, resulting in negative 20 over 3, or negative 6 2/3. All right, number 17. Take a look. We've got subtraction going on. I only see 1 after, so this is a chop slash situation. Okay. Chop slash to this. There we are. We got to convert these into improper fractions. 8 times 8, 64, plus 3 is 67. keep your negative, don't drop it out. 10 times 6 is 60, plus 1 is 61. Don't drop your negative. Okay, and then I'm going to think what number could go into both 24, or what number could I make with both 8 and 6? Well, if I think about it, 24 would be the first option I have. Okay, so I'm looking to get to where both of these are over 24. Okay, 8 times 3 gets me there. 6 times 4 gets me there. Okay, 67 times 3 is 21. 3 times 6 is 18, plus 2 is 201. So I get negative 201 over 24. And then 61 times 4 is 4, and then 244. Again, don't drop out your negative. Okay, 201 over 24 plus negative 244 over 24 ends up being, we would have 5, 4, and 4, negative 445 over 24. Okay, if we go and divide this out, okay, that doesn't go in, but this goes in once. And I'm left with 20. And then I'm going to think, well, 5 times 24 is 120, plus 24 would be 144, plus another 24 would be 168, plus another 24 would be 192. So that would work out. So this would be 8, and that's 192. Subtract that out, and we get 13 left over. So I can say that this is negative 18 and 13 24ths. Okay. All right, 2 more to go. Now we're working with decimals here. Again, same thing's going on. In this case, I have 1 negative after the first number, so this is a chop slash situation. Chop slash. Okay, I'm adding 2 negative decimals together, meaning I'm just going to add them and take the common sign. Okay, this would be 3, that's 11. Keep your decimal, and that is 8. My common sign is negative. I should have negative 8.13. For number 20, now I see there's 2 after the first number, so this is going to be a chop chop. Negative 7.34, chop chop. Make this positive. Okay, I have 2 opposite signs here, a negative and a positive, so we're going to subtract their values. 7.34 is the bigger value, so we'll put that on top. Okay, 4 minus 1 is 3, I got to borrow here. 13 minus 5 is 8, 6 minus 5 is 1. Okay, I get 1.83. Check to see which had the greater value. It's this one, it's negative, so my answer is negative. Okay. Number 27 says you have 2 and 2/3 ounces of sodium chloride. You want to replicate an experiment that uses 2 3/4 ounces of sodium chloride. Do I have enough sodium chloride? If not, how much more do I need? All right, basically what it's asking us to do is compare these 2 values and see, is 2 2/3 greater than 2 3/4, and if it's not, how much more would I need? Okay, so let's start by taking what we have and trying to take away what we need. Okay, so 2 2/3 minus 2 3/4. Well, we can rewrite these to be 8/3. 3 times 2 is 6, plus 2 is 8, minus, and this would be 4 times 2 is 8, plus 3 is 11 over 4. Now from here, I see I have 1 minus sign, so I'm going to chop slash, and then I need to make common denominators. The least common multiple between 3 and 4 is 12, so we're going to convert both of these to have a 12. This would be times 4. This would be times 3. Okay, so I have 32 over 12 plus negative 33 over 12. Okay, 32 minus or plus negative 33. Well, I'm going to subtract those 2 values, and I get 1. Okay, my bigger value this time is negative. So I have negative 1/12 remaining. Here's what that means. Okay, do I have enough sodium chloride? No, I do not have enough. I'm negative. I'm missing something. Okay, if not, how much more do I need? Well, I would say I need 1/12 ounce more. Okay, that would make up for my missing. Right, I want to get back to 0. Lastly, number 28, when is the difference of 2 decimals an integer? Explain. Ooh, good question. So, if we think about any decimal, right, throw any decimal out there, 5.83, and I want to end up at an integer, right, we have to think, well, an integer is a positive or a negative whole number, so a whole number or its opposite, meaning I want to end up with no decimal points. Okay, the only time I can ever get there is, let's say I was to subtract this, right? I want the ending to be 0, 0. Okay, you could have chose 3 after, you could have just chose 1. Okay, what I need to do is ensure that the decimal places are the exact same, in which case I end up getting a number that has no decimal point after, which means I could just simplify this, in this case, to 2. So when is the difference of 2 decimals an integer? Okay, it would be when their digits after the decimal point are equal. Okay, so if I had 5.83, this means that my other number would end in 0.83. Okay, and my explanation is kind of right there. Okay, showing it has to be that way, otherwise this won't be an integer. Okay, all right, moving to the back side, we've got 30 and 32 here. This time I am going to be using some different ways that we can move around numbers in a sense to help us solve this a little bit easier. Okay, so one thing I can do is we can use our commutative property, which says I can move around anything within an addition or subtraction problem as long as I bring the sign with it. Okay, so here what I'm going to end up doing is I'm going to flip-flop these two values. Now I'm going to check and just see, okay, I have 2 negatives right there, meaning I can flip-flop the numbers good. If I had like 1 plus and then 1 minus, I would have to take the signs with them. In this case, since they're the same, it's not really going to matter. Okay, the reason I'm going to do this is you'll see I'm trying to line up my common denominators right next to each other. Okay, looking here, I have a chop-chop situation, right? I'm subtracting a minus, so this is going to be adding a positive. Okay, so we have 2/5 plus 3/5 is 5/5, which we know 5/5 is 1. Okay, so now if I were to kind of bring this part back up, okay, this would be the other part of my equation, minus 7/10. Okay, well, we know we can write 1 as 1 over 1. And if I wanted it to have a base of 10 or a denominator of 10, I could just write 1 as 10 over 10. That equals 1. So take away 7/10 from that, and we're left with 3/10. Okay, for number 32, again, I'm going to do the same thing here because I want to do everything I can to get all of my common denominators done first, and then if I have to change, I can. Okay, again, I'm going to check. I've got 2 subtraction signs. I'm good to switch these 2 numbers around. Okay, so we've got 1 3/4. Okay, minus, and then we'll get 1 1/4, minus -8 1/3. Okay, if you're asking, could I just do my karate math right away and then switch them? Absolutely. In fact, when we have both negatives and positives, or pluses and minuses in there, it might be a little bit easier to do it that way. That way you're always working with either positives or negatives. Okay? So now I can go ahead and I can do my chops and slashes if I need. Both of these are going to be chop chop. Okay? first things first, I need to convert these. So 4 times 1 plus 3 is 7 fourths. That's negative. 4 times 4 plus 1 is 17 fourths. And this would be 25 thirds. Okay, starting with my common denominators there. Negative 7 fourths plus 17 fourths. Okay, they have common denominators. One's positive, one's negative, so I'm going to subtract these two. 17 minus 7 is 10. 17 is the bigger value, it's positive, so I have 10 over 4. Okay, I just did this part right here. Okay, 10 over 4 plus 25 over 3. Again, I'm going to think what's my least common multiple between the 4 and 3. It's 12. So we're going to change each of these to be over 12. 4 times 3 is 12, so 10 times 3 is 30. 3 times 4 is 12, so 25 times 4 is 100. We're going to end up with 130 over 12. Okay, I could simplify this by dividing by 2. I get 65 over 6. Okay, that works. Or I could have it be, right, 6 can go into 65 10 times. And then there would be 5 6 left over. Okay. The next three, finding the distance between two numbers on a number line, right? On a number line, we're trying to think about it as what's the distance total between these. Okay, so 0's right here. 8.4 is going to be way over here in the positives, and negative 2.2 is going to be a lot closer to 0, but it's going to be over there. Again, to find the distance, we're going to take the greatest number we see, which in this case is 8.4. Okay, 8.4, and we're going to subtract our smallest value. Okay, what's going to happen in this case is it's going to make sense that when we chop, we're really just adding, because I need to add this distance to this distance. Okay, so 8.4 plus 2.2 is going to be 2, there we go, 6, 10, meaning the distance between these two numbers on a number line is 10.6. Okay, next up, on a number line, both of these are negative, so they're going to happen after the 0. If I think about where about 3 would be, it would be right about here. And then negative 7 would be a lot further to the left. Again, my bigger value, or my biggest number in this case, would be negative 3 2/3. It's further right. So we're going to take negative 3 2/3, and we're going to subtract negative 7, which means I'm going to chop. Okay. I'm going to move this to above. I'm going to convert this really quick. 3 times 3 is 9, plus 2 is 11 over 3. And then we have plus 7. I'm going to write that over 1 because I can. How am I going to change 7 over 1? Well, I'm going to multiply the top and bottom by 3. And I'm going to get 21 over 3. Negative 11, positive 21, they don't like each other. They're going to subtract. 21 minus 11 is 10. I'm going to keep it positive since distance is always positive, and it will work out for this to be positive. Okay, I have 10/3, which if we simplify is 3 1/3. Right, which makes sense because if I were to add negative 3 1/3 to this, I would actually end up right at negative 7. Okay, lastly here, again, on a number line, this would look something like this. They would have 0 right here. Negative 1 1/3 would be pretty close to it, and 12 7/12 would be way over here. Okay, I'm going to take 12 7/12, subtract a negative 1 1/3. Again, this makes sense that I'm going to actually be adding positive here because I need to go beyond 0 and adding more distance. Okay, so converting 12 times 12 is 144, plus 7 is 151 over 12, plus 1 times 3 is 3, plus 1 is 4 over 3. I need to convert 4 over 3 to have a base of 12. 3 times 4 is 12. meaning on top 4 times 4 is 16. Okay, 151 plus 16, both of them are positive. I'm going to just add. I get 167 over 12. Okay, trying to simplify this down a little bit. I know that, well, 144 would be 12 times 12. If I go one more, plus 12 would be 156. And then if I tried one more, it'd be 168, so I can't do that. So 156 is going to be the biggest, which is 13 12s. And there would be 11 12s left over. Okay. Number 45, a new road that connects a Uniontown to Springville is 4 1/3 miles long. What is the change in distance when using the new road instead of the instead of the dirt roads? Okay, so basically what we want to see is how far was the original route, which would be going down from Springville, taking this left turn down to Uniontown. Okay, so we're going to add 2 3/8 and then 3 5/6 together. Okay. When I add those two together, I need to convert here. So 8 times 2 is 16 plus 3 is 19 over 8 plus 6 times 3, 18 plus 5 is 23 over 6. Okay, my most common denominator there would be 24. And then I get, let's see, so this would be times by 3. 19 times 3 is 57. 6 times 4, so 23 times 4 would end up being 92. Adding together there, we get 149 over 24. That is the total distance of the old route. Okay, from here what we're going to be doing is we need to put this onto a number line. Okay, so my 0 would be over here. I want to convert this back into a mixed number just so I can kind of compare it really quick. So if I was to do that, I'm going to think how many 24s can fit into 149. Can't there, can't there. 24 times 5 is 120. If I add another 24, I get 144. And that's all I'm going to be able to do. So I get 6. And then when I take away here, I'm at 5. So this is also equal to 6 and 5/24. Okay. If I think about that, that means 4 1/3 is going to be right here. And then 6 and 5/24 ends up being right here. All right, our next step from here is we've got to figure out how far apart is 4 1/3 and 6 and 5/24 away from each other. So I'm going to use the other version that we already had, 149 over 24. Knowing that that's my greater value, I know that I'm going to end up subtracting 4 1/3 away. Okay, 4 1/3 is going to change into 13 over 3. And now from here I have to make common denominators, right? So I've got this times 8, this times 8. 149 over 24. This will be 24 on the bottom here, and now 13 times 8. I get 24. 8 times 1 plus 2 is 104. So from here I can change this to a chop slash. 149 minus 104 is 45. So we get 45 over 24. Looking at this, I can see that I can take out a 3 out of both of them. So this would end up being 15 over 8. Okay. And then 15 over 8 simplified would be 1 7/8. So when it says, what is the change in distance using the new road instead of the dirt roads? Well, it's 1 7/8 shorter. And if I want to say shorter, I'm using negative. So I'm going to say it's negative 1 7/8 difference. It's that much shorter. Okay. Two more here. Number 53 says that the bar graph shows each month's rainfall in comparison to the historical average. Okay, and then what is the difference in rainfall of the wettest month and then versus the driest month? Okay, and then what do you know about the total amount of rainfall for the year? Okay, so basically this line right here that goes through the middle is on average in history, how much rain did they get? Okay, anything above our line says that during this month we got more than what we should expect. Anything below would say, hey, this is less than what we expected. Okay, so for part A, I'm looking for the one where we got the most amount of rain, which would be 2.36 over what we expected. And then the driest month would be the one where we had the least expected on average. Okay, so for part A, I'm going to take my most rainfall month, and we're going to subtract. Looking here, all of these are negative, so really this is a negative 1.67. And when we add both of these, we're going to do 2.36 plus 1.67, which will get 13. That's 10 and 4. Okay, so we would say that there is a difference of 4.03 inches of rain. Okay, so it rained that much more during July versus April, than average. Okay, for the total amount for the year, we would need to look at adding up all the times where we were above our rainfall average and all the times we were below our rainfall average, and kind of compare for the entire year, where am I actually at versus the historical average. So what we're going to do is we're going to add up all of our positive values first. So I have 0.94, 0.83, which gets me 1.77. And then we're going to add our 2.36, which is 4.13. And then we're going to add 1.39. And finally 0.35. Okay, so in the months where we had more than expected, we had 5.87 inches of rain more than we expected in those months. Okay, for the ones where we didn't reach what I want, we're going to have 0.45 plus 0.88, which ends up being 1.33. And we'll add 1.67, which gets us exactly at 3. And then adding 0.96, 3.96. Adding 1.35. 11, 13, 5.31, plus 0.9, which brings us to 6.21. And then finally adding 1.39, which takes us to 7.6. Okay, so I have, in the months where I was above, I went way above by 5.87. In the months I was below by 7.6. Okay, last step for this is we're going to take those two values, okay, and we're going to add them together, but remember all of these red values are negative, so really we're adding negative to it. A positive plus a negative means I subtract. 7.60 minus 5.87. I'm going to borrow here. 10 minus 7 is 3, borrow again. I get 7, and then I get 1. So, for the total rainfall for the year, okay, since our negative values were greater, it means we were negative, meaning we had 1.73 less inches of rain. Okay, finally for 57 it says fill in the blanks to complete the decimals. Okay, I have 5 point something 4 minus something point something equaling negative 3.61. Okay, in my head, here's what I'm seeing. If my answer is negative, and I started with a positive answer, that means that this has to be a bigger number if I'm taking it away. Okay, so I'm actually going to put that on top. I'm going to take away 5 point something 4 to get me to 3.61. And the reason I changed it from negative to positive here is because at the end I would change it to negative, but I want to figure out what this was in the first place. Okay, and now we can kind of start filling in the pieces here. So if I had this, I want something minus 4 is 1. Well, this would need to be 5. How do I get to 6? Well, I could do this actually a couple different ways. I could do 9 and 3. I could do 8 and 2. Or I could do 7 and 1. I'll stick with that. Doesn't really matter. Finally, to get to this, I could do something minus 5 is 3. That would be 8. So, filling in my blanks, what I have is this was 5.14, and this is 8.75. And when I do that, I end up at negative 3.61.